Alright, hello guys. In this next video, this is going to be our first video on how we solve rational functions like this. So the method I'm using is not the universal method of solving these. There's a ton of different ways you can solve these. I just like the way I do them because it works kind of for all problems. So you can use it for these problems, for the next video, the video after that, for all these problems. For the other ones you do, those other methods can kind of work for different types of problems. You got to kind of figure out, okay, can I do it this way? Can I do it this way? This method is kind of just like a procedure you can follow for all of these problems. So we need to start off with these problems doing something off to the side, and that's finding our excluded values. So as you guys know, for rational functions, you cannot have a zero in the denominator. So we're going to have these things called excluded values, which are numbers that you cannot plug in for x, because if you were to plug in these numbers, it would give you something over 0, which is undefined and it doesn't work. So you have to look at these three denominators and figure out what would you have to plug into x to make that 0. Well, this is just x. So if you plugged in 0, this would become 4 over 0. So our first excluded value is 0. This one, if we plugged in -5, this would become -5 plus 5, which becomes 0. And this is the same thing. -5 plus -5 plus 5 becomes 0. So our second excluded value is -5. So off to the side, we found that whatever this simplifies down to, we will not be able to plug in 0 and -5. Those are our excluded values. So the next thing I do to solve these is I like setting these equal to 0. So I move this over to the left side. I get everything on one side. And since this is a negative, to move it over the other side, you're going to have to do plus. So if this was like a positive 5 over x plus 5, then you would subtract it. And this would become this plus this minus this. But since this is already a negative, when you're moving it to the other side, we add it. So we're left with okay, now my next goal is I want all three of these to have the same denominators. So that's what I'm gonna do. I'm gonna mess with each of these three pieces so that each one of them has the same thing in the denominator. And the way I kind of think about it is I look at each denominator separately and I figure out like how many different pieces there are to this puzzle. So we have an x, we have an x plus 5, and we have an x plus 5. So there's only two pieces, x and x plus 5. And so each of our denominators, if it's like this where it's missing an x, then we just give it an x plus 5. If it's missing an x, like these two are, we're going to give it an x. And remember, whatever you do the bottom, you have to do the top. So this one is missing an x plus 5, so we're going to give it an x plus 5. So we do it to the top as well. This one is just missing an x. We give it an x. This one also just missing an x. My bad, you have to do it on the bottom too. And so now we do this, all three of these have the same bottom, they have the same denominators. So we can write this as one singular fraction with just x times x plus 5 on the bottom. And on top, we're just taking this plus this plus this. So 4 plus x times x plus 5 times x. Now we distribute. When we do this, we're left with 4x plus 20 plus x times x is x squared, so plus x squared plus 5x we can reorganize these. We're just left with x squared plus 9x plus 20 So now what we're doing is, if you guys remember this, this all equals 0. That should be an arrow. That should be an arrow. And this equals 0. So if you remember with a fraction, for a fraction to equal 0, you don't worry about the denominator. You only worry about what's on top. So that's all we're going to do is we're just going to focus on what's on top, and we're going to set that equal to 0. So we're going to take x squared plus 9x plus 20, set that equal to 0. So we factor it. Remember, if you have an x squared and set equal to 0, you just can't factor it. So we have 20, 9, so that's 4, and 5. So this becomes x plus 4 times x plus 5 equals 0. We split this off into two directions and solve them separately. So we have x plus 4 equals 0, x plus 5 equals 0. So we got the answers -4 and -5. But we're not quite done. We have one little extra step. Because now we need to compare the answers we got with the excluded values we got. And if any of these are repeating, so if any of our excluded values are also an answer, then we cross them out because they cannot be both. If they're an excluded value, they cannot be our answer. So our excluded values are -5 and 0. And one of our answers is -5. So we cross that out, it's no good. Our only actual answer is -4. And now we're done.